3 in our velocity-based training series brought to you by GymAware. This module, we're going to talk about the force velocity curve, or as I prefer to say, our load velocity curve. Our industry is pretty synonymous with what is termed the force velocity curve. If you've been around a few years within the industry, you've probably seen it, heard of it, maybe even studied it amongst a number of your postgraduate studies or undergraduate studies. When we look at it, the concept is fairly simple. It's basically looking at how we have a nice relationship between load and velocity. We talk a little bit about force velocity. As I said, I much prefer load. We can ascertain some really good force output that maybe doesn't necessarily require a higher load. But when we talk about load, we can see a really strong relationship between load and velocity. The heavier load we're working with, the slower we're going to move it. The lighter the load, the quicker we're going to move it, to an extent. Obviously, as we get lighter, it is all about intent and making sure that we're keeping speed, because it's very easy to get lazy and drop off. Hence what I'm going to talk about a little bit down this end with our things like scoop toss and how VBT can actually help us with that. But when we look at our load velocity curve, we can start with our bookends, which I've already referred to in our previous modules. Deadlift as an example, maximum 1RM type movement, slow, grindy, a lot of force into the ground, a lot of load on the bar, going to move very slowly. When we bookend that with our velocity side of things, something like a scoop toss, where we have this really expressive velocity movement. You could almost argue coming down here could be our overspeed work, like our accelerative-based stuff. So when we talk about bookends, we kind of get it. Fairly simple, most people understand that. When we talk about the middle, where the magic happens, it becomes a lot harder. This is where the true grinding velocity and load relationships start to occur, and it becomes most important from an athletic standpoint to look at how we can utilize velocity as a variable measure to make sure that we're achieving the outcome that we want to achieve. And to know when we're starting to shift up towards our heavier bookend or shifting down to our faster bookend on our force velocity curve. Because when we know that, we know how we're starting to shift an athlete. We understand where we're trying to push them and why. So we're going to go through a testing and assessment module in a few modules to give a better understanding of how we can start to analyze these. But to give a bit of an intro into the force velocity side of things, when we look at the failure threshold, or at least failure velocity of most lifts, if we're looking at an upper body lift, typically between 0.15 and 0.2 is when we will see the last rep occurring. Yes, there's some variations based on how advanced a lifter is. Someone that is far more advanced with lifting will usually be able to grind through sticking points a little bit easier at a slower rate. People that are very new to lifting will never be able to move a weight this slow without failing beforehand. So we can see upper body around that 0.15 to 0.2, so something like a bench press. And then our lower body failure is around 0.2 to 0.3. So if the bar starts to move at about 0.3, we kind of know that we're getting close to either our last or second last rep, depending on how advanced that individual is. So if we can start to see loads that initially start at this for a 1RM, but then we can start to track loads of the same magnitude that actually start to move quicker, we can start to see that it starts to move that athlete's ability from here and slowly speeds it up down that force velocity curve to allow a little bit of a shift of their potential, and hopefully, obviously, will increase their 1RM because they're going to be able to lift a higher load at this failure velocity. But what's unique about this as well, it doesn't matter if it's a 1RM or a 5RM. When we get to the last rep, they all tend to look similar. If we have a 1RM, the first and only rep, if it's a failure rep at a lower body, will probably sit between here. If we use a 5RM, once we get to reps 4 and 5, they slow down to this speed as well. So it's a really good indicator for us to understand when an athlete is approaching failure. We can use it in a very simple way of having our VBT unit stuck onto the bar. If it's a bench press or a squat, it may not be using velocity as a variable. We may be using it as a feedback tool. So as an athlete starts to slow down, they maybe get a 5RM and their last rep is maybe 0.4. We can probably ascertain that they've got a little bit more in them. Whether they believe it or not, we know that the velocity they've achieved on that last rep has still some significant decrement that it can occur to allow us to really find that true 5 RM. So can we add a little bit more? In saying that, can we look at how we can increase the rep range? If it is a 5 RM and they are hitting 0.4 on that 5th rep, maybe we say, right, we can add a couple more reps. Let's try and hit the same load, but we're going to go for 6 reps or 7 reps. Based on the velocities of the previous set, we can ascertain that they're probably very likely to get it. And it's a really good confidence booster for the athlete and a really good understanding feedback mechanism for them to utilize to know whether to push or to pull. So that's talking about this end of the force velocity curve. If we come back down to our high speed end, this might be unloaded jumps. We can now start to see, well, in this example, load isn't typically the issue. The issue is being able to sustain a high velocity output. And we also know the old adage of train slow, be slow. If we're trying to make a shift in high speed movements, well, we want to make sure that those movements are actually fast. We know when working with track sprinters that they need to have options and opportunities to run as fast as they can. Hence why they have a lot of rest. They have a lot of timing setups going. Are they hitting the right time? Are they doing what needs to be done without fatiguing too much and therefore not having the carryover to the high speed outcome that we want? In the gym is exactly the same. If we're doing jump work, if we've got, say, unloaded dowel rod, we've got a belt that we're using the GymAware unit on, or we're doing upper body throw work, it might be, and we'll go through this, but it might be things with a landmine that we're throwing the landmine and starting to judge the velocity. If these things are starting to drop off, well, we're no longer working here. We're slowing down and shifting into this area, but we're not shifting in this area because we're getting heavier. We're shifting this area because we're fatiguing. So if fatigue is causing this shift to occur, then we need to be aware of that. And we need to know when to call the set. So as an example, we might use the velocity-based training options down here, but we're using them not necessarily to ascertain whether we're hitting our maximum 1 RM. We're using it to make sure that our intent and our speed outcome is being maintained. If the speed starts to drop slower than, say, 1.3, we might call it 1.5, we might even go up to 1.6 depending on the movement. But we say that we don't want you to go any slower than 1.5. We know that the outcomes that we're achieving every single rep are there. And as soon as that speed drops, we cut the set, we give them the rest period, we go again. And often we might see sets start at 4 or 5 reps, then 4, then 3, and then maybe 2 if you've prescribed that number of sets. But it's important to understand when to cut the set and how much rest to give. Because within that scenario, we may actually give more and more rest between each set to make sure we keep getting the volume of exposure at that speed that we want. They're the bookends. Now, when we come into the middle, this is where the magic happens. This is where we create some real impulse monsters. Ones that can move high-ish loads at high-ish velocity. And there is such thing as we don't want to be too in the middle where we're not getting stronger or not getting faster. But when we look at power outcomes and what a lot of athletes have to go through in sports, i.e. in contact sports, where they're tackling, hitting, grabbing, throwing, trying to accelerate out of positions where they're being held onto, this type of grind is something that I really value in a lot of my athletes. And using VBT allows me to make sure I'm shifting the curve in the direction I want to shift it. If I'm selecting a weight and saying, right, this 100 kilos, I want to see it getting faster and faster and faster. I know that if that velocity is going up, my power outcome is going up, but I do not need to change the load of the bar. I may decide it might be an in-season option where I go, I actually don't want to put more load onto an athlete's back. I don't want to deadlift more load. What I want to do is increase the power of this movement. Therefore, I'm going to target, right, that's the load, it's fixed, but the velocity is the thing that we're going to track. We're going to track every rep, every set to make sure that we're either holding a specific velocity, and typically I use that magic 1 meter a second. I really like seeing speeds above 1 meter a second with loading to be able to drive that high speed adaptation. And so I start to see, well, can I achieve a greater speed week in, week out with that load? And then as they start to adapt to it and we start to plateau out, well, I can start to change the load. And I can then look for a higher velocity based on that change in load. But I can still maintain the same, if not more, power output. So I can start to manipulate whether I'm prescribing a fixed load or a fixed velocity. And then the alternate will be, if it's a fixed velocity, well, they just alternate load based on what they need for that week to achieve the velocity that I've selected. And the variation is true. If I fix the load, then we're trying to achieve a velocity. As soon as that velocity is not hit, then we cut the set or we increase the rest time. So hopefully this gives you a really good foundational understanding of why we may program the way we do and how we can start to add it in as a better variable than potentially just our traditional variables. In Module 6, we're going to dive in a little bit deeper into what that actually looks like in a program and practically. But until then, this will serve as a really good visual for your understanding.